Section 5.7, inverse trig functions. All right, let's take the sine function. Looks something like this, okay? Y is equal to sine of x. Now, if we look at, we want to talk about an inverse function. A function needs to be 1-to-1 to have an inverse function. Well, remember the easy way if we have a graph to see if it's 1-to-1 or not with the horizontal line test, right? And if your horizontal line crosses the graph at more than one place, is not 1-to-1. Well, crosses 1, 2, 3, 4. If I keep going, it crosses forever, right? So this function is not 1-to-1 like it is. So I need it to be 1-to-1. So what if I talk about this function, but I talk about getting rid of all this part right here of this function and getting rid of all this part of the function, okay? And I just have this piece of my function right here, okay? All right, so this piece of my function is for negative pi over 2 to pi over 2 right here, okay? Now, if I look at this part of my function, it is 1-to-1. It passes a horizontal line test. So now I could talk about this function as having an inverse function. And the inverse function we denote as like inverse sine or arc sine. Okay, these mean the same thing. Just some books use this notation more, some books use that notation more. Well, let's sketch what the graph of the inverse function looks like. I'm going to go ahead and use this. I'm going to go ahead and use inverse y is equal to the inverse sine of x. All right, how do you graph an inverse function? What is an inverse anyway? Basically just inverting each one of the ordered pairs, right? So let me sketch a graph of my inverse function. All right, so if I'm inverting the ordered pairs, think about this for a second. These first numbers are values in my domain, right? The second number of my ordered pairs values of the range. So I'm basically inverting the domain and the range. So instead of my x-axis going from negative pi over 2 to pi over 2, I'm going to look at my y-axis going from negative pi over 2 to pi over 2. And my x-axis now is going to be from negative 1 to 1. From negative 1 to 1. Now let's plot these points. So I'm going to invert each point here. What happens if I invert pi over 2, comma 1? I'll get 1, comma, pi over 2. Let me go ahead and plot that and label it. How about 0, 0? If I try to invert that, what do I get? Same thing. 0, comma, 0. What about this order pair? Well, what will I get? Negative 1, negative pi over 2, which is right here. Negative 1, comma, negative pi over 2. And this graph, like, really to get it more accurate, we need to pick many more points on here and then invert them and so forth. But this graph looks something like, somewhat like that. It's a pretty poor picture of it. But you can look at the book and they have a much, much prettier picture. You can go online and look at pictures of the inverse function or whatever, okay? But know that you get it by inverting the what? The ordered pairs. And also that you have to restrict the sine function between negative pi over 2 and pi over 2 to get the inverse sine function. All right. So next your notes talk about the inverse sine function, and they basically define it, okay? They say the inverse sine function denoted by inverse sine or arc sine is the inverse of the restricted sine function. And then it goes on to say y is equal to the inverse sine of x. And then we have a double-headed arrow here. And then we have the sine of y is equal to x. So we could read this as you can go from this form to that form or that form to this form with the double-headed arrow, okay? But y is equal to the inverse sine of x means you could write it as the sine of y is equal to x. All right, so let's talk about, let's suppose I have this. Let's suppose I have the inverse sine of 1/2, okay? Let's go ahead and put y is equal to on it then. And we're going to say this reads, one way to read this is y is the angle whose sine is 1/2, where the angle y is between negative pi over 2 and pi over 2. In other words, like that, okay? So what does this basically read? Y is the angle that falls between negative pi over 2 and pi over 2. Notice they can include each one of those. So y is the angle between negative pi over 2 and pi over 2, whose sine is 1/2. All right. So how does that help us? That really helps us out a lot in our first example here. Let's look at this first example. It says find the exact value or state that the expression is undefined. And then for part A, hey, what do you know we have here? We have inverse sine of 1/2, okay? All right, now notice I don't have y is equal to the inverse sine of 1/2. I just have inverse sine of 1/2. But I could say that this, I'm looking for with this, the angle that falls between negative pi over 2 and pi over 2, whose sine is 1/2. Think about that for a second. I'm looking for the angle that falls between, so I'm looking for some angle, we could call it theta or y or whatever we want to call it. I'm looking for the angle that falls between negative pi over 2 and pi over 2, whose sine is 1/2. So if I think about the unit circle, here's what I'm looking at. This is negative pi over 2 right here. If I go from here to here. If I go from here to here, that's like positive pi over 2. So where do I have an angle that is between negative pi over 2 and positive pi over 2, whose sine is 1/2? Well, think about your sine values over in this quadrant. They're negative, right? So that won't give me an angle whose sine is positive 1/2. But angles in this quadrant may give me, or an angle in this quadrant will give me an angle whose sine is 1/2. And think about that angle. Isn't an angle right here where you have a sine that is 1/2? What is the sine? The second number in the order pair, right? Yeah. And what is that angle that gives you that? Pi over 6. So the answer to this would be pi over 6. Let's look at part B. Part B. Part B, what I have is the arc side, just a different way to write this. Arc side of negative 1/2. All right, so what does this mean, first of all? I'm looking for the angle that falls between negative pi over 2 and pi over 2, whose sine is negative 1/2. Let me draw a picture of that again, okay? I'm looking for the angle between negative pi over 2 and positive pi over 2, whose sine is negative 1/2. Well, my sine values are negative over here, right? In quadrant number 4 here. And think about where you have the second number in your order pair, because remember your order pair are cosine, comma sine. Think about where you have a sine that's negative 1/2. That would be at this reference angle of pi over 6, right? But if I think of rotating that way, I have to say that's negative pi over 6. So the angle that falls between negative pi over 2 and pi over 2, whose sine is negative 1/2, is negative pi over 6. Right now would be a good time to pause, well, after I put up part C. After I write up part C, like this, the inverse sine of negative square root of 3 over 2, now would be a good time to pause the video. Try to work this one yourself. And once you're done, hit play and see if you got it right. Alright, so what does this mean? The angle that falls between negative pi over 2 and pi over 2. So I'm looking for the angle that falls between negative pi over 2 and pi over 2, whose sine is a negative square root of 3 over 2. That'll be in this quadrant, right? Sine is the second number in the order pair on the unit circle. Where do I have this? Square root of 3 over 2 for the second number. I have that at this angle, which is what? Negative pi over 3. So the answer here is negative pi over 3. Now do y'all see why I had y'all memorize those values on the unit circle? So much easier, so much quicker if you have those memorized. How about D? How about arc sine of 3? So what are they asking for here again? They're asking for the angle that falls between negative pi over 2 and pi over 2, whose sine is 3. Where do I have an angle whose sine is 3? What do my sine values do on the unit circle? Think about this for a second. What do my sine values do? Okay, we talked about pi over 6 radians, or we talked about 0 radians first of all. What do we have? We had the point 1 comma 0. Then we had the point what? If we go around pi over 6 radians, we had a point square root of 3 over 2 comma 1/2. And then at pi over 4 radians, we had the square root of 2 over 2 square root of 2 over 2. Then at pi over 3 radians, we had the point what? 1/2 square root of 3 over 2. Then we had the point at pi over 2 radians, 0 comma 1, right? And then basically these numbers kept kind of repeating themselves over here, in here, but maybe they had different signs on them, okay? Alright, but notice, what is your sign starting at 0? It goes through these numbers. It goes through other numbers between here, but notice that it never gets bigger than 1, or it never gets smaller than negative 1. So the angle that falls between negative pi over 2 and pi over 2 whose sine is 3, it's not defined. Okay, so we put undefined. Undefined. All right, let's look at the inverse of the cosine function now, okay? All right, think about your cosine function. If you were to draw it, if you were to make a drawing in cosine function, y is equal to cosine of x. Y is equal to cosine of x. And what does this function look like if we graph this? Okay, here is 2 pi, here is pi, here's pi over 2, here's 3 pi over 2, but here's 1, here is negative 1. And then on this side, I could do the same thing, right? I could say that's negative 2 pi, I could say that's negative pi, and so forth, okay? All right, so your cosine function starts here, ends here over one period, goes down here, goes through there, and it does something like, oh, completely missed that point. There we go, and it keeps on going in that direction. It does a real similar thing over here, right? Just like that and so forth. Well, you can see from this drawing that this function is not one-to-one at all. So we need to talk about restricting our domain before we could talk about an inverse function. And here's what we do. We get rid of all this stuff right here. And we get rid of all the cosine function stuff over here. And what we did is we restrict the domain between 0 and pi for my cosine function. And what point would this be then? This would be the point 0, comma 1 on the graph. This would be the point pi over 2, comma 0 on the graph. And this would be the point pi, comma negative 1 on the graph, okay? Now there are many other points. I'm just labeling those 3. All right, but notice I restricted my domain between 0 and pi. So if I want to talk about y is equal to the inverse cosine of x, the graph of it, and I want to draw a picture of it, I'm going to say, okay, I have an x and a y axis, but now my x-axis goes between -1 and +1. My y-axis is going to go at least from 0 to pi right here. And invert each one of these ordered pairs. So I'll have -1 pi on this graph. -1 comma pi. I'll have what? 0 pi over 2. So 0 pi over 2. And what else? 1 comma 0. 1 comma 0. And let's go ahead and draw this with a curve that looks something like this. Okay? Now the big graph of y is equal to the inverse cosine of x. All right. What did we restrict the domain on this thing to? 0 to pi, right? So whenever I'm looking at something like this, the inverse cosine of, say, 1/2, how is this read then? This reads, or one way to read it, I could say, is the angle, what we're looking for here is the angle theta or y or whatever you want to call it. I'm going to call it theta here. The angle theta, where theta falls between, what did I restrict the domain? From 0 to pi. Or theta falls between 0 and pi, whose cosine is 1/2. Okay? If you read it that way, it's going to make doing these problems much, much easier. All right, so let's look at the inverse tangent next. Inverse tangent. Now, I'm not going to go through the formal definition of the inverse cosine and inverse tangent here, just to save time. All right, y is equal to the tangent of x. What we do with this function is we restrict the domain between -pi over 2 and pi over 2 here. And we only look at that one period that does that. So what does my tangent function look like? Something like this, right? All right, remember it has a bunch of other periods that go like that, another one that goes like that, but if I draw all those other ones, it's not going to be 1-to-1. So if I only look at the domain of my tangent function for -pi over 2 to pi over 2, then it's 1-to-1, and it has an inverse function. What is this inverse function going to look like? Well, here's what it's going to look like. Let's draw coordinate plane, call it an x-axis, we'll call that a y-axis. Now it's going to have a horizontal asymptote at -pi over 2, another horizontal asymptote at +pi over 2. This was the point 0, 0, and if we invert that, we still get the point 0, 0. And our graph's going to look something like this. Like if we were to pick more order pairs on the graph of this thing and then invert them, we would get something that looks like this. For time's sake, I'm just going to give you all what this thing looks like. right, let me ask you this now. What does this read? This reads the angle theta, where theta falls between what? What do I restrict this domain to? Negative pi over 2 to pi over 2. Where theta falls between negative pi over 2 and pi over 2. Whose tangent is 1. Just like the others, right? Except I don't have the equal to sign here because my tangent function is undefined at pi over 2 and negative pi over 2. So I do not have the equal sign there. All right, so remember, what do you restrict the sine function to? From where to where? Negative pi over 2 to pi over 2. What do you restrict the cosine function to so we can have an inverse function? 0 to pi. What do you restrict the tangent to? From negative pi over 2 to pi over 2, but you don't include both of those endpoints.